Hi students, welcome to Vipin Sharma Physics class. Today I'm going to tell you something, a basic concepts from day-to-day life. Acceleration due to gravity. Here we go with it. You know, when you talk about the acceleration due to gravity, see this boy is throwing the ball is dancing down, right, in the ground. He's throwing, just pushing it. Now it falls off its own just because of gravity. You know, very interesting, simple, but physics is behind it. So, an object is in free fall when it falls to the earth under the sole influence of gravity, that is called free fall. Means the, the apple, you know, from this balloon, hot air balloon, he just releasing this is coming down because of gravity, right? So, the parachutist, they are coming down by virtue of gravity. Of course, it is not a free fall. Of course, gravity pulls them down, but here is a lot of this air and that is opposing it. A body under the influence of the Earth's gravitational field can be a body dropped from a certain height, experiences gravity. So, gravity is a wonderful observation. A body under the influence of Earth's gravitational field can be a body thrown vertically downward from a certain height. From this building, you release this, it's falling down, the ball is dancing down. That is gravity. Similarly, this boy who is just there with a ball, stone, it falls down, that is due to gravity. From hot air balloon, that is direction is down, gravity. One dimensional motion. So gravity is what, it is an attraction of the planet. The acceleration of a freely falling body due to gravitational force, that earth is acceleration due to gravity g, measured in meter per second square. Acceleration is measured in meter per second square. So the gravitational force, generates acceleration in the mass which is being dropped. It's falling down with g, meter per second square. That is 9.8 meter per second square. So, dear students, you understand anything which is released, you know, and released from a height, it falls freely. That is on account of the gravitational force of attraction. Now, see, the earth is having a mass capital M, small m is the object, right? D is the distance of the object from the earth, and now R is the radius of the earth. Okay, and when you talk about the gravitational force of attraction, it is F is equal to M into capital M upon D square. Small m is the mass of the what do you call object. G is the acceleration due to gravity. Force is equal to mass into acceleration mg. Now this force, which is equal to mg, is generated by Newton's law of gravitation. Newton states that every material body in this universe attract each other. So product of masses square of distance, F is equal to G capital M upon D square. G is called universal gravitational constant and D is the distance of the object from the center of the earth. R is of course the radius. So F is equal to G mm by R square. If object is lying here, if it is at a distance capital D, then G mm by D square. Now if you equate 1 and 2, F is equal to mg g mm by R square, mg is equal to G mm by R square, and G is equal to gm by r square. See, mass of the earth, radius of the planet earth, capital G gravitational constant. So what do you find? You find that acceleration due to gravity is independent of the mass of the body. So r is maximum at equator, r is minimum at polar. Well, that is another concept. So hope this concept is crystal clear, that what is g, acceleration due to gravity. It is independent of the mass of the body. Now, dear students, see, the earth is having radius maximum at equator and minimum at the polar. Now, if you talk about the g is maximum where? At the equator? No, at the polar. And minimum at the equator, because the radius of the equator is more, distance of the object is more at equator than on polar. And g equal to what? G mm by r square. If we substitute the values, capital G is 6.6710 to minus 11 Newton meter square per kilogram square, and mass is 6 into 10 to raise power 24 kilogram. Our radius is 6.410 to 6 meter. So you find the value of gmm by r square. So that is 9.8 meter per second square, or 9.78 meter per second square, or 9.77 meter per second square, but we take 9.8 meter per second square all over the world, and average value of g. So that's all about this concept. Now, dear students, I'm going to show you something very interesting. The acceleration due to gravity is independent of the mass. I have two balls here. One is metal ball and one is the wooden ball, of course of the same size, but obviously heavier is metal ball because of its density. And you see that metal ball is there and wooden ball is there. Now we release both fall simultaneously on the ground, because g equal to gm by r square. G, capital M, mass of earth, r is the radius of earth. So it is independent of the small m, that is the mass of the falling object. So the force on metallic ball is greater than force on wooden ball, of course, because mass of the metal ball is greater. F is equal to g, capital M, into small m, that is wooden, small mm, that is metal. So acceleration due to gravity, but for the metallic ball, and acceleration due to gravity for the wooden ball is equal. So acceleration due to gravity is independent of the mass of the body. So hope it is clear to you all guys what I've told you and explained you. Thank you very much. So hope this topic is crystal clear. I will be uploading the videos in the two versions. One is in English version and other is Hindi version. So this is for those students who understands only in English, and the second version will be in the Hindi as well, right? So thank you very much. If you like this, fine. We do like it that you liked it. At the same time, we are going to launch online classes, and that classes will be taught on the Google or Zoom. For that, you can WhatsApp 981 for 121996. Classes are starting from the new session in April. Thank you very much.